Hello, I'm Derek Hitchins, and I'd like to talk about the rigorous soft methodology. First of all, what is it? Well, it's a thorough, scientifically based method for addressing messy, intractable problems or issues. It generates requirements for problem and issue resolution. It addresses the most complex and abstract and obscure of issues, and it's a serious, heavyweight alternative to Checkland's soft systems methodology. Interestingly, perhaps, it's mathematically provable. Here are some of the examples of different viewpoints that one might address using RSM. Concern about an organisation's morale, but no obvious culprit. Differing views of causes for lack of performance, effectiveness or efficiency. Burgeoning social unrest, but no single cause and no evident remedy. Or perhaps concern over global warming and future sources of energy at national level. And many, many more. How does one go about solving complex problems, at least in principle? One way is to use a procedure such as this, in which a couple of well-known problem-solving paradigms have been bolted together. The top half of the diagram is the so-called general problem-solving paradigm, and the bottom half is the well-known systems engineering problem-solving paradigm. Let's go on. If you went along to the doctor and said, "Doc, I don't know what's wrong, but I feel out of sorts," he would probably think that you were a bit of a waste of space. However, he would start to look for causal factors and symptoms. And he would ask, what do you do? What's happened to you recently? And he then check for deficiencies, excesses, out of balances in urine, blood, electrolytes, etc. And the greater a variety of symptoms that he could find, the greater the prospect of a correct diagnosis. What he would do if he was really puzzled, he'd postulate potential causes for each symptom, and then potential causes common to several symptoms. Hence, diagnosis from causes common to many or all symptoms. And the rigorous soft methodology acts on similar lines. Let's see it as 7 steps. You can see my young doctor there. Step 1, appreciate the broad area of concern. Step 2, find the symptoms causing concern. Step 3, find suspect implicit systems. These are systems in the body implied by the symptom. Group suspect implicit systems into sets, highlight set deficiencies compared with the ideal, and propose a remedy. Check that the remedy would eliminate all of the symptoms. If it doesn't, you've probably got it wrong. There's it in iconic form. The rigorous soft methodology, this is the standard graphic, going from clockwise from 1 right the way round to 7 in a number of steps. There's a check at the centre there. If you find that you have cured all the symptoms potentially, then you've got a solution. If you haven't, then you've got to do it again because you've got something wrong. You can also see it as a procedural loop. This one goes anti-clockwise, starting at the top with nominate issue and issue domain. And you can go around the circle there to 3A, 3B, 4, 4A, 4B, 5, 6, 7, and finally 8, nominate the potential issue resolution. There's a little more detail in there, but not as much detail as there is in the RSM as a behaviour diagram. This is a typical 3-column behaviour diagram. The centre column, the centre panel, contains functions or processes or activities going from top to bottom. And we can see here we start with identified symptoms of issue, problem or dysfunction at the top, and we should end up with a fair wind at the bottom with formulate remedial system solution. The right hand column is a series of outputs. starting with at the top recognised symptoms, and then issue and factors, laundry list and so forth, and going right down to the bottom to putative issue remedy. The left-hand column, on the other hand, is sources. So if we read this across from left to right, at the very top we see an input, source, intelligence and information, going into identified symptoms of issue, problem and dysfunction, and coming out of that we get recognised symptoms. And so on down the whole panel. You have inputs on the left, a process in the middle, and outputs on the right. So this is quite a sophisticated and elegant way of presenting a process. But to be honest, you can look at these diagrams and it doesn't help very much. Let's go through a particular example, see it working. And we'll have a look at the nuclear energy issue that was mentioned earlier. So here we are, national energy, solving, resolving or dissolving the issue using the rigorous soft methodology. And I have to say this is a real-world case. The situation is explained broadly here. There is uncertainty about the future of nuclear power. Activists are protesting about both the danger from power stations and the difficulties of waste disposal. Illnesses, particularly infantile leukemia, are being ascribed to radiation from power stations, although scientists are unable to detect any causal relationship. Government is concerned too about public opinion and about the massive cost of decommissioning power stations. The alternatives seem uncertain too. Fossil fuel is problematic, with the cost of coal rising slowly but inexorably. The availability and cost of oil is always a problem, associated as ever with a volatile Middle East. Government has committed too to reducing greenhouse gas emissions. The major generator of CO2 is fossil fuel. If CO2 emission control is to be realised, it seems inevitable that fossil fuel burning will have to be reduced. But how? And if there is to be no nuclear industry, what is the future source of energy going to be? A new factor has arisen, a road link to the continent. This promises to reduce the cost and time of freight, including perhaps oil imports, but it also carries a threat of ingress from undesirable elements. What to do? There seems to be no sensible way forward. And you can see that I've highlighted a number of statements here as being potentially symptomatic. I've picked them out on this next table, symptoms 1 to 4, and you can see what I've picked out. The government in this particular country had driven themselves into a corner several years earlier by committing themselves to dispensing with nuclear energy altogether. Now that was coming home to roost. So here we are, we're starting off with the first symptom, activists are protesting. You can see that at top right under the heading symptom. If we backtrack to the centre panel, possible causes, you can see what the analysis suggests might be the possible causes of these activists protesting. That could be fear of nuclear accidents or weapons, fear of radiation illness, concern over the environment, but also a wish to bypass the democratic process and a wish to impose some minority viewpoint on the majority. Those are not independent of each other, and so some additional information may be gained by combining them into a causal loop model, such as that seen at the bottom left. And you can see there, if we think about standards of operation and management safety in the middle, they should lead to public education and awareness about nuclear energy particularly, and therefore public commitment, which would lead to a nuclear industry inspectorate reinforcing standards and causing upgrades to the energy system, which would improve public education and awareness and so forth. So we can actually see a positive feedback mechanism here, making the public aware and committed to nuclear energy. Unfortunately, it's been going the other way in this particular country. They haven't had open publicity, and so there hasn't been public commitment. If there was public commitment, there would not be, filled in arrowhead meaning negative, if there were public commitment, there would not be activists protesting. And the activists, of course, are very keen to have a much better inspectorate if they have to have anything. At the right here we can see by going around the loop what the various implicit systems are that are in imbalance, and we do that simply by reading it off around here and connecting them up. The next symptom was concern over radiation illnesses, and that could have been possible causes. This is the locus of possible causes. Fear of radiation, lack of scientific evidence allowing rumours to arise, and of course the need for a scapegoat. That again can be turned into a causal loop model at the bottom here. If we had objective scientific research, it leads to open publicity and public education and awareness, and that would reduce any suspicion of nuclear radiation. And that suspicion at the moment is fueling the idea that it's causing infantile leukemia. And the objective scientific research should have found a cause or a cure by now, but as it hasn't, we don't know. Let's try another one. Perceived danger from nuclear power stations. Well, the laundry list of possible causes is our designs are unsafe, or at least a perception that designs are unsafe. It could be that activists are naive or wrong, or simply out to make trouble. It could be that poor designs are in use. It could be that power stations are located near centres of population. And it could be that the public and young people are not given sufficient access and education. And you can once again see a causal loop model here. We're talking about public confidence, activists, public education, perceived danger, and it all does actually bulk together, such that we can see imbalanced systems, educating public, promoting public confidence. They're not in balance, they haven't been doing it. There's not been any education of the public, so there's been no promotion of public confidence. Here's a more familiar one, rising costs of fossil fuel. Possible causes? There's a perception globally of dwindling resources, although we do seem to have plenty of resources for the next 50 or 60 years. However, perceptions are more important than reality. Supply countries are restricting flow to raise prices. That seems to be true. Supply countries' view of the current inelastic market. They do believe they can raise prices without it causing them a problem. Supply countries' awareness of the West's move away from fossil fuel. If they know that their customers are not going to be using the fossil fuel that they supply, then they might want to get their money's worth while they can. And the government has imposed tax to encourage alternative energy sources, all of which makes potentially the rising costs of fossil fuels. If we look down here, we can see what's going on. We've got oil prices, reducing oil consumption. The West are dependent on it. Oil supply rates, you can see there's a positive feedback loop there with problems coming from it. Oil consumption leads to CO2 emissions worldwide, which lead apparently to global warming. And global warming leads to actually a threat on renewable energy and its relative prices. And we'll see why that comes about later. Enough on that one. Government commitment to reduce greenhouse gases. What could be the possible causes? International pressure, need to pacify the environmental lobby, maintenance of national image, need to avoid danger from global warming. And once again we can see these coming together. This is a much more interesting perhaps. We have, let's see, concern for the environment from government, leading to them to take part in the Kyoto Accord. That gave them international respect, which enhanced their national identity as being a nation concerned with the environment. That concern for the environment talks about CO2 emissions, and CO2 emissions control would control global warming. Global warming leads to rising seas. Global warming leads to rising temperatures. Rising temperatures lead to some renewable energy, solar energy for example, and that enhances the national identity because they're using renewable energy sources. Rising seas threaten coastal populations, however, and coastal populations are part of the national identity. This one's a little more problematic around here. CO2 emissions controls would result in a reduction in fossil fuel burning. But fossil fuel burning actually enhances national economic performance at present. And national economic performance enhances international respect and national identity. There seems to be some problems about the arrows there, whether they should be positive, hollow or negative filled in. It doesn't actually make any difference over here, as you will see. The new road connection to the continent. I won't go into that, but it's more of the same. They can all be put together, and when they're all put together you find that the whole background of this is really quite complicated with lots of things going on in parallel. There's no new information in there. I've just joined up things that were in different ones. So the oil consumption here is joined to oil consumption in that one. Public commitment in this one is joined to nuclear economic power, economic value over there, which the public should be committed to. We've got all sorts of connections across here, but the main ones have been filled in. That's a bit difficult to deal with. What's going on there is far too complicated to see all in one go. But if we tot up all the implicit systems that we've come across and group them together, it looks something like that. And you'll see there are repeats there. For example, there's public commitment under radiation and leukemia, and up here under nuclear power, and so on. Let's put those into an n-squared chart. Now there's no new information here, we've just presented exactly the same information in a different way. These numbers, 1 or 2, 1 or 1, they represent the number of times and the linkage. So there is a connection from public commitment to objective research. In other words, the public are committed to objective research. Now what we've done here is clustered those others and we've symmetricalized it to make it easier to see. And the first thing you notice is that we have some patterns here that have come up. There's a pattern there about J, where all the various interfaces in the n-squared chart are filled in. J is control of CO2 emissions, so it's a nodal point, and nodal points are signified by such vertical crosses, like that, crosses of George sort of shape. And when there's a gap there, there's a significant something missing, usually. In this case, if you look at it, what's missing is any relationship between the control of CO2 emissions, which is J, and renewable energy sources, which is O. And clearly there should be some relationship in there. This one here is a little more subtle. If you look carefully, you'll see that this half here is not actually connected to the rest at all. And so it suggests that it's a completely different subject. They're not the same in the same system. When you look at it more closely, you'll see that something's missing. E here, which is public commitment, should be connected to sustained nuclear power. And somehow that's been missed in the previous analysis. So we can use the n-squared chart here to pick up on anything that's been missed. Having added in what's been missed, we recluster it and we get a different pattern. There's the filled in node now, it's moved around on the table. And let's now see what happens when we try and divide this into groups. What we're actually doing here is moving up a hierarchy level and finding out what the containing systems are. Now I've used a simple computer tool to do all this, but for many years I worked n-squared charts like this without anything other than pieces of paper and lots of head scratching. So this can be done without any tools at all on a bit of paper, moving the various rows and columns about to get the patterns to emerge. And what's happened here is that we can see that the groups on the left have become containing systems. There's a group here which is all about nuclear energy. There's a group here which is all about environment and energy in general other than nuclear, but that they have an overlap in the idea of sustaining nuclear energy there. That's the only thing that connects those two halves up there and down here, is that one there. And if we look here, down the bottom, we find this is all about environment and energy, and environmental concern there is common to this group, and it's also common to this group, and it's the only thing it is. So we've got three containing systems, and we've got overlapping systems that are in the middle in each case. If I present that in a rather more digestible form, it looks like this. And I have reintroduced the pejorative terms that we started off with. So we have nuclear energy on the left, environment and energy in the centre, and national sovereignty on the right. And linking in each case the various circles, left and centre we have in the middle, failure to sustain nuclear energy is the issue in the middle there between those two. And on the right, environmental concern is from between sovereignty and environment and energy. And you can read there, all I've done is reintroduce the pejoratives which are in the background. So for example, failure to educate the public has resulted in ineffective inspection standards and lack of public commitment. And on the right we have threatened economic credibility and prejudiced national identity and integrity. And in the middle there we have dependence on expensive and unreliable oil supplies. We have potential for continued global warming and ineffective control of CO2 emissions, and impending prejudice to international trade. It is a characteristic of the systems interaction diagram that it pulls no punches. Now, we can develop a causal loop model from these high-level ones, and I've chosen to do just the energy bit in the middle. If we start at the top, we see that oil and coal consumption lead positively to increased CO2 emissions. So as we increase oil and coal consumption, we inevitably increase CO2 emissions. And they inevitably contribute to global warming, which results in rising seas, shifting patterns of rain, wind and temperature. And although people don't seem to think about this very much, those changing patterns caused by global warming actually threaten renewable energy supplies such as hydroelectric, wind power and tree farming. People don't think about that. Now, the renewable energy supplies, if we can increase them, mean that we can reduce the amount of nuclear energy that we have. Only it seems unlikely that we can increase our renewable energy supplies because they're threatened by global warming. And nuclear energy we need to reduce our oil and coal consumption. Now the fact of the matter is you can only make that loop behave rationally by retaining nuclear energy. It doesn't work otherwise. How much is another matter, but you must retain some nuclear energy to square the circle, as it were. Otherwise it's irrational. Putting that together with the other, the sovereignty and the national commitment, you can see the causal loop model now for the whole thing. That's much simpler because we come up a level than was the one we showed earlier, which looked like a frenetic spider had got loose on the page. Now this presents the government of this country with some optional strategies. They could continue or even increase the use of fossil fuels. They could phase out nuclear power, increase CO2 emissions, maintain their international trade and their national economic performance, and simply renege on the Kyoto Accord. Or they could retain, sustain, enhance nuclear energy, reduce oil, reduce emissions using mixed energy sources, maintain international trade and national economic performance. Or they could phase out nuclear and fossil fuel, control CO2 emissions, accept reduced industrial and transport capability, accept reducing international trade and national economic performance. That's about the size of it. If they go the way they're going to have to do one of these three. Which one? Let's compare the options. In the first one, we have activists protesting, and we have symptom 2, the cost of coal is rising, and so forth. 3, governments committed under the Kyoto Accord, and 4, the new road connecting to the continent is seen as a two-edged sword. And what we want to see is if our proposed solution solves and resolves all the original symptoms, and there they are, 1 to 4. So, option 1. It clearly doesn't deal with symptom 2 because the cost of coal is rising, and in option 1 we start to use more coal, not less. It doesn't satisfy number 3 because it doesn't reduce gases, and government has committed under the Kyoto Accord. So it satisfies 1 and 4 but not 2 and 3. Okay, let's look at option 2. Well, that's the nuclear option. That would be solved because the nuclear safety would be greatly enhanced, and visibly so. You wouldn't have to be dependent on coal and oil. You would reduce CO2 emissions, and the new road would not be seen as a problem. So option 3 doesn't quite work. Option 1 doesn't quite work. And option 2 is just about viable. So the rigorous soft method is enabled the conduct of an orderly, thorough examination based on very few initial facts. The arguments and ideas are explicit. Anyone is able to observe and disagree, provided they can refute the logic. Overall, it's a powerful approach to a sensitive and seemingly intractable problem. What do you think? Right, let's have a look at some of the details of how this is done now. So look at some techniques. We use systems models, you've seen some of those. How can we? Cause and effect analysis, we've seen that. Why analysis, we haven't seen that. Causal loop modelling, you've seen some of that. Poetic, you've seen that, but I didn't bring it out. Dynamic system modelling, N-squared you've seen, and CAD-RAT is the N-squared charting software. And system diagramming, you've seen the systems interaction diagram. Each of the techniques is useful on its own, but when you string them together so that the output of one becomes the input to the next, you get a suite of techniques for addressing the most complex of issues rigorously, because no information gets lost en route. And other techniques can be plugged in. Okay, a system scientific view of problems and symptoms. Well, very familiar, babushka Russian dolls. Systems exist within systems, supposedly ad infinitum. Looked at diagrammatically, we see what's rudely referred to as the Hitchins poached egg systems model. This is a general purpose model showing a system of interest, bottom right, with 3 intra-connected subsystems within it, could be any number. And then the system of interest finds itself within an operating environment along with 3 other sibling systems, and they're all together within a containing system, which has connections to other containing systems not shown. So we have basically a hierarchical or containing arrangement here. This is a reference so that we know where we are when we're doing systems work. The trouble is, systems are often quite less distinct than that. May be difficult to see. System boundaries may be fuzzy. Systems may overlap each other. They may exist in two or more systems at once. The trick is that we can use emerging symptoms of malaise or order to probe under the surface and detect the root sources of problems. Trouble with symptoms is they arise where the problem isn't. You can see on the left an excess output can produce an oversupply in something downstream, or a reduced output can produce an undersupply, and in both cases the symptom emerges downstream. If you look at the right-hand diagram, if something changes in A, where will the symptom of the change occur? The whole thing is fully interconnected. It might even occur, having gone all the way around the circuit, it might even occur at A, but the chances are it's going to occur somewhere else. Laundry lists. You've seen these in use. Let's see how they come about. Here's a simple example. We all know what perspiration is caused by. It's caused by exertion, or possibly high temperature. It could be high humidity, or it could be an illness. And the laundry list mentality helps generate possible causal factors. But the process misses out the relationship between the causes. Now, the causal factors may not be mutually independent. Seeing the relationships adds greatly to understanding. So here we have temperature rising, causing perspiration, causing evaporation, causing latent heat of evaporation, which reduces temperature. Right, the evaporation causes an increase in local humidity, and the local humidity reduces the rate of evaporation. So if you're wearing one of these sweatsuits, you start to sweat inside, but after a while you start to get hot because although there's lots of sweat coming off you, it can't evaporate. Sweat sometimes gets lost as droplets, and that reduces the available body fluids. So does passive water, and you may need to up your fluid intakes. So when you've got a temperature and you're ill, the doctor will often tell you to drink fluid, and that's to stop you becoming dehydrated, which will make your temperature go up even more. So the simple act of looking at perspiration produces a causal loop model, which is looking quite sophisticated. We haven't even begun to look at the whole model here, because we would have to look at what happens when you get cold, which is a quite different physical phenomenon. Creating the idealized system. Using pejorative terms in the laundry list exploits a natural human behaviour. We are much better at seeing deficiencies than possible benefits. We all like to be critics. Dropping the pejorative term when developed the causal loop model from the laundry list produces an idealized organization of features. This is a seemingly simple process, but it can produce results which are almost miraculous at times. We start with the symptoms of an issue. We then use those symptoms via the simplest of methods to produce an idealized world model, which appears without any special effort on our part. We then compare the idealized world model with the reality from the symptom sets to identify differences and shortfalls. Now, you've also seen the system's interaction diagram, and it looks something like this. And it's something you can show your boss, who's much too busy to concern himself with the detail, but actually all of the detail is here, but presented in a high-level form. So the SID summarises the likely issue sources. Containing deficiencies propose their own remedies. Interaction deficiencies between containing systems also propose their own remedies. Matched set of issue resolving requirements emerge, and the set is tested against the original symptoms to verify completeness and relevance. Note that all the requirements have to be met. To meet only some is to risk counterintuitive response from issue symptoms. And lastly, a mathematical viewpoint. I won't bother to go through this, but this is sets, mathematics of sets. We have an issue here. We have sets of symptoms. The set of symptoms become unified into a union of sets. We then put those into the n-squared region. Remember, we find intersections, disjoint sets, subsets, and functionally bound sets. And we have a grouped structural shortfalls traceable back to the issue, multiple parallel requirements to address the issue. And it all turns out to be mathematically sound. So, in summary, this has been a brief introduction. There are more examples of his application to different problematic situations at the given references, the last reference being 3 books. But the best way to learn is to try RSM out on a simple problem, issue or situation in a familiar domain just to get the hang of things. And after that, well, how'd you get to Carnegie Hall? Lady, you gotta practice. Good luck.